Right now, without thinking about it, you are connected. Not to a single machine, not to a single server, not to a single company, or a single country, or a single anything. You are connected to a network of networks. Hundreds of thousands of separate computer systems linked together, spanning every continent, carrying billions of messages every second in every language on Earth. You call it the Internet. And if someone asked you who invented it, you would probably say one of two things. Maybe Al Gore, the old joke, the one that won't die. Or maybe you would say Tim Berners-Lee, the British computer scientist who created the World Wide Web in 1989. Both of those answers are wrong, or rather, one of them is a joke, and the other describes something that is not actually the Internet. The Internet and the World Wide Web are not the same thing. Most people treat them as synonyms. They are not. Understanding the difference is the key to understanding where the Internet actually came from, who actually built it, what it was originally designed to do, and why the story of its invention is far stranger, far more complicated, and far more interesting than the version you probably know. To understand the Internet, you have to start in 1957, not in a laboratory, in the sky. On the 4th of October 1957, the Soviet Union launched a satellite called Sputnik into Earth's orbit. It was small, about the size of a beach ball, and it did nothing more than transmit a simple radio signal. But the implications were enormous. If the Soviets could put a satellite in orbit, they could put a nuclear warhead anywhere on the planet. The Cold War, which had until that moment been a war of missiles aimed at fixed targets on the ground, was suddenly a war of objects moving overhead, tracking anyone, striking anything, at any time. The American response was immediate. Within a year, the United States established the Advanced Research Projects Agency, ARPA, a government organization with the specific mandate of ensuring that American technology never again fell behind the Soviet Union. ARPA was given broad authority, significant funding, and unusual freedom. It did not need to justify every project in terms of immediate military application. It could fund basic research, speculative ideas, things whose value might not be clear for years. One of the problems ARPA decided to attack was communications vulnerability. The American military communication system of the late 1950s was built around centralized networks, systems that routed messages through specific exchange points. If those exchange points were destroyed in a nuclear attack, the network would fail. The entire communication infrastructure of the United States could be disabled by targeting a few key nodes. What was needed, some researchers argued, was a fundamentally different kind of network. A network with no center. A network where every node was connected to multiple other nodes, so that if any one node was destroyed, the messages would simply route around it. A network that was, by its architecture, indestructible. This was not the Internet, not yet, but it was the idea that would eventually become the Internet. The theoretical foundation for what would become the Internet came from two independent sources working on the same problem at almost the same time. In 1960, an American computer scientist named Paul Baran, working at the Rand Corporation, published a series of papers proposing a communications network based on what he called distributed communications. The key innovation was not the network itself, but how messages would travel through it. Instead of sending a message as a single, continuous stream, the way a phone call works, where a dedicated circuit is established and held open for the duration of the conversation, Baran proposed breaking messages into small chunks. Packets. Each packet would carry not just a portion of the message, but the address of its destination. The packets would be released into the network individually, finding their own way to the destination by whatever route was currently available, and reassembled into the original message at the other end. This was packet switching. It was a completely new way of thinking about communication, and it had enormous advantages. A packet-switched network had no dedicated circuits to destroy. If a node failed, the packets simply routed around it. The network was resilient by design. It could handle many different conversations simultaneously using the same physical infrastructure. And it was scalable. You could add new nodes without disrupting the existing ones. At almost the same time, and entirely independently, a British physicist named Donald Davies at the National Physical Laboratory in London was developing the same concept. He even used the same word, packet. Neither man knew about the other's work until later. The idea had arrived simultaneously, as fundamental ideas sometimes do, because the underlying problem was clear, and the solution, once you saw it, was almost inevitable. In 1966, ARPA hired a computer scientist named Lawrence Roberts to build an actual network based on these principles. Roberts had read both Baran's papers and Davies's work, and he set about designing what would become known as ARPANET. On the 29th of October, 1969, ARPANET transmitted its first message. It was sent from a computer at UCLA to a computer at Stanford Research Institute, 400 miles away. The message was supposed to be the word login. The system crashed after the first two letters. The first message ever sent over what would become the Internet was low. In the years that followed, ARPANET expanded. More universities, more research institutions, more government agencies. By 1973, it had connections to nodes in Britain and Norway, the first international links. But ARPANET was not a public network. It was a research network funded by the US Department of Defense, accessible only to researchers with institutional connections. The general public had no access to it, and for most of the 1970s, no particular awareness that it existed. What was happening during this period, more importantly than the physical expansion of the network, was the development of the protocols, the shared languages that allowed different computers to communicate with each other. Early ARPANET nodes communicated using a system called the Network Control Protocol. It worked, but it was designed for a single network. As ARPA began to think about connecting multiple different networks together, radio networks, satellite networks, packet networks of various kinds, a new protocol was needed, one that could handle the diversity. In 1974, Vint Cerf and Bob Kahn published a paper proposing a new protocol. They called it the Transmission Control Program. It was later refined and split into two separate protocols, the Transmission Control Protocol and the Internet Protocol, TCP/IP. TCP/IP is the language of the Internet. Every device connected to the Internet today communicates using TCP/IP. Your phone, your laptop, the server that hosts every website you visit, the router in your home, all of them speak TCP/IP. Without it, the Internet, as we know it, could not exist. Cerf and Kahn did not invent the Internet, but they created the foundation on which everything that followed was built. The Internet, in the sense of a network of networks, all communicating with the same underlying protocol, came into existence on the 1st of January 1983, when ARPANET switched from the old Network Control Protocol to TCP/IP. That date is sometimes called the official birthday of the Internet. It was not covered by the press. nobody noticed. Before we go further, there are names that need to be said. The history of the internet is often told as the history of a few famous people: Barron, Cerf, Kahn, and then Tim Berners-Lee. But the actual development of the network involved hundreds of people, many of whom have received almost no public recognition. Leonard Kleinrock at UCLA developed the mathematical theory of packet switching and ran the node that sent that first message to Stanford. He has spent years pointing out gently that packet switching was a mathematical insight before it was an engineering one. John Postel, who managed the assignment of addresses and protocols for the early internet for decades from a server in his office at the University of Southern California, was described by some as the person who ran the internet from his bedroom. He did it largely without pay, largely without recognition, because someone had to do it, and he understood it better than almost anyone. Elizabeth Jake Feinler ran the ARPANET's Network Information Center from 1972 to 1989, maintaining the directory of every host on the network, the predecessor of the domain name system. Without her work, finding anything on the network would have been nearly impossible. Her name appears in almost no popular history of the internet. Radia Perlman, in 1985, invented the spanning tree protocol, the algorithm that prevents loops in network routing and makes large Ethernet networks possible. She is sometimes called the mother of the internet, a title she reportedly finds both gratifying and slightly annoying. Her work is invisible to every person who has ever connected to a local network. These are not footnotes. They are the people who actually built the system, the ones who made the decisions, solved the problems, and wrote the code that turned an abstract idea into a working global infrastructure. Here is the thing that most people do not understand. When Tim Berners-Lee invented the World Wide Web in 1989 and 1990, the internet already existed. It had existed for 20 years. It was running. People were using it. They were sending email, transferring files, connecting to remote computers. The internet of 1989 was not the internet of today. It was slower, text-only, inaccessible to most people, but it was real and functional. What Berners-Lee invented was a layer on top of the internet, a way of organizing and navigating information that used the internet's infrastructure but was not itself the internet. Berners-Lee was working at CERN, the European Particle Physics Laboratory in Geneva, when he proposed, in March 1989, a system for sharing information between researchers. The problem he was solving was not communication. The internet already handled that. The problem was organization. CERN had thousands of researchers, thousands of documents, thousands of pieces of information that needed to be findable, linkable, and accessible to people who didn't know in advance what they were looking for. His proposal was called Information Management, a Proposal. His supervisor wrote on it, vague but exciting. It was the birth certificate of the World Wide Web. The key innovations were three things that now seem obvious because we use them every day. Hypertext, text that contains links to other text, allowing readers to navigate between documents non-linearly. URLs, Uniform Resource Locators, a standardized way of addressing any document on any computer connected to the internet, so that a link in one document could reliably point to a document on any other computer anywhere in the world. HTTP, Hypertext Transfer Protocol, a standardized language for requesting and delivering those documents. In December 1990, Berners-Lee had the first web server running on a computer at CERN. By 1991, the web was accessible to the public. By 1993, a young programmer named Mark Andreessen had built Mosaic, the first web browser with a graphic interface, and the number of web users began to double roughly every few months. The World Wide Web was not the Internet, but it made the Internet usable by everyone. In April 1993, CERN made a decision that is, in retrospect, one of the most consequential decisions in the history of technology. They released the World Wide Web into the public domain. No patents, no licensing fees, no restrictions. Anyone, anywhere, could use the web protocols, build web servers, write web browsers, create websites, for free, forever. This was not inevitable, it was a choice. Many of the technologies that had come before the web, from the telephone to the radio to early networking protocols, had been locked behind patents and licensing agreements that shaped, often in limiting ways, how they developed. Berners-Lee himself could have patented the web. His invention was clearly original and clearly valuable. He chose not to. He later said that if the web had not been free, it would never have become what it became, that the explosive growth of the 1990s depended entirely on there being no barrier to participation. He was right. And that decision, made by a committee at a physics laboratory in Switzerland, is the reason the web looks the way it does today. By 1995, there were 20,000 websites. By 1998, there were over 2 million. By 2000, there were 17 million. The growth was unlike anything in the history of communication technology. Faster than the telephone, faster than television, faster than radio. A new medium was not just added to the world, it began to absorb all the others. The Internet today is the largest machine ever constructed by human beings. Not in physical size, though the physical infrastructure is enormous, a planet-spanning network of fiber optic cables running under oceans and through deserts and along the walls of buildings so ordinary you walk past them every day without noticing. In complexity, in interconnection, in the sheer quantity of human communication and thought and creation that it carries every second. And it was not designed to be this. No one planned it. No one drew a blueprint for the global Internet of 2024. What exists today emerged, messily, accidentally, chaotically, from a series of decisions made by researchers, engineers, and administrators who were mostly trying to solve specific, limited problems. Paul Barron wanted a network that could survive a nuclear strike. Cerf and Kahn wanted different networks to talk to each other. Berners-Lee wanted physicists at CERN to share documents more easily. None of them were building the Internet as we know it. They were building the next small piece of something that no one yet fully understood. The Internet also has costs that its inventors did not anticipate. The same openness that made it grow explosively has made it vulnerable. The same absence of central control that makes it resilient also makes it resistant to governance. The same global connectivity that lets a researcher in Lagos share data with a colleague in Seoul also lets a government surveillance system monitor every message its citizens send. The people who built the early Internet were, almost universally, optimists. They believed they were building something that would connect humanity, democratize information, give voice to people who had been voiceless. And in many ways, they were right. But the thing they built also became something they did not build and did not intend. Something they are still collectively trying to understand. On the 29th of October, 1969, Leonard Kleinrock and his team at UCLA sat at a computer terminal and typed the letters L-O-G. The system crashed. Charlie Klein, The student who had sent the message called his counterpart at Stanford on a regular telephone to tell him what had happened. The first message on the internet was confirmed by phone. Lo, it is, unintentionally, one of the most evocative first messages in the history of communication. Not, "Mr. Watson, come here." Not, "What have God wrought?" the first telegraph message. Not even the Morse letter S that Marconi sent across the Atlantic. Just, lo. An accident, a system crash, a fragment, and then, from that fragment, everything. The internet was not invented by one person. It was not invented for you. It was not invented to sell you things or connect you to friends or give you access to all of human knowledge from a device in your pocket. It was invented piece by piece by researchers and engineers who were trying to solve specific problems, and who, in the process of solving those problems, built something that neither they nor anyone else fully anticipated. That is how the most important things usually get built, not by a single genius with a plan, but by many people over many years solving the next problem in front of them and then stepping back to see what they had made. The network runs. The message arrives, whatever it says.